All right, ladies and gentlemen, we are ready for quiz 1 into unit 4 here. As you can see on a little post-it here, I know most of our previews are always almost identical to what we're looking at on a quiz or test, but this time we're going to throw a little twist in. You'll notice on your review that there are not 13 questions, but there will be on the actual quiz. There's going to be a couple more like these first two, where you're having to make some decisions on growth and decay. You know, how do you determine it, domain, things like that. And there's going to be one more app, but there'll still be formulas right there for you as well. So, all right, warning out of the way. So, let's see here. State whether the function represents growth or decay. Then give the y-intercept and the end behavior. Okay, now, could I just type this into my calculator? Sure. Am I going to just type this in my calculator? No. Here's why. I noticed something right away on both of these. I don't see plus or minus numbers afterwards or in the exponents, which means there are no shifts. That's going to actually make my life easier. Because when I'm looking at whether this is growth or decay, all I have to do is look at my b value. Now don't get sucked in here. A lot of you are going to look at that, you're going to see that it's a fraction and go, ooh, it's decay. But let's think about this for a minute. If I type 5 divided by 2 in my calculator, that's 2.5. That's greater than 1. So this is going to be growth. Because remember, growth occurs whenever my b value is greater than 1. Okay. My y-intercept, a couple of ways I can do this we've talked about before. The y-intercept occurs when x equals 0. Could I type this in my calculator and look on the chart? Sure. But since there's no shifts, I can go ahead and get this put in. Well, let's do both. Like, Harty, you are way too random here, changing your mind on things. Well, I always like to let us see that this can work multiple ways. So I type this in my calculator, I look at my chart. Go to where x equals 0, I see 0, 3. And now you can see, oh yeah. Okay, this is really just going to be 0 in my a value, as long as there aren't shifts going on. But if there are, I have to pay attention to those. Warning, you may have to do that on the quiz tomorrow. Hint, hint, wink, wink. Okay, so domain and range. Now this, I don't blame you if you may want to look at a picture of it. So we'll go ahead and we'll pull the picture for this part. Okay, there's my picture. I see the growth that I'd expect, up to the right. My domain, which again is always the easiest part of all of these when we're talking about growth and decay, is negative infinity to infinity. Range, if there's no movement, okay, always is going to have a 0 and an infinity somewhere in it. So here my range would be 0 to infinity. Well, what if I don't realize that right away? Well, first I can see it. It's getting really close to 0, but it's not passing. I also could look at it in my chart, because notice the numbers keep getting smaller and smaller closer to 0, but they're not going into the negatives. Another thing to ponder. And then finally, my end behavior. Remember, my x's always go with my domain, because that's what domain is. X values left to right. So that part should be easy. Excuse me. But then my f of x's, remember, are just a fancy way of saying y equals. So it's going to be these two values, but I got to figure out which one's which. So as I look at this, as x goes towards negative infinity, as x goes to the left, and labeling that probably not a bad idea, is y getting closer to 0 or going up forever? Well, it's getting closer to 0. So that's what I put in here. Y approaches 0 as x goes left. Yes, it does. Then I go down to the bottom one. As x approaches positive infinity, which means I'm going to the right, my graph goes up, 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 up. Okay, I'm not going to be getting into a musical anytime soon. So y goes up as x goes right, which is true. And I'm done with that one. Now when we get to number 2, again, it's starred for a reason. Something we've talked about, but it doesn't happen very often. Normally I'd look at this and I'd say, hey, b is 1/2, it's decay. But let's take a look at this for a minute. And make sure we're very careful when we're typing to notice there's a negative x as my exponent. Okay, the negative, not a minus, but negative. Let's look at the picture of this and see what happens. Wait a minute, that looks like growth again. How's it growth? Because my b value is a half. Okay, this negative exponent causes my b value to flip. So this, even though it's written this way, is going to act as though it's this, or I could even say that's 2 over 1. Okay, negative exponent will cause that, negative x. So in that case, if it's 2 over 1, that'd be growth. And I see that when I type it in on the calculator anyway. My y-intercept, just like we said before, even though it flipped, is going to be 0 in my a value. If I want to double check, I can always look at the chart. Okay, there it is. Domain doesn't change. Range doesn't change. You're like, I kind of like that part. You know, not a lot to have to think about. In my end behavior, since my graph looks basically the same as the other one did, should act the same end behavior-wise. But even if I wasn't sure, my x's don't change. As x goes left, I'm getting closer and closer to y being 0. As x goes right, I'm getting closer and closer to y going up forever to positive infinity. And you can see how we're talking here. Okay? So if you are more comfortable looking at the picture, that's fine. But a lot of the information you can get without it even. But watch out. Negative exponent. Remember, that causes that flip. All right. So the next ones, we're just going to be doing some graphing. Again, your choice on how you want to deal with the graphing portion. I have a feeling a great many of you are going to go the calculator route here. Let me get it where we can actually see it here. Again, make sure that when you're done with your exponent, that -2 isn't up here. It's on the end. So right arrow over to make sure that happens. I'll pull my chart up. And again, I'm not always going to see whole numbers everywhere. That's okay. I'm going to sort of look, though, to start seeing, oh, I see it's sort of getting closer and closer to -2 as I go along here. Oops, I'm going the wrong way with that. I got to pay attention myself to these. That's better. Again, I don't have to put every single dot in, but it doesn't hurt to get quite a few so I can make sure my graph is fairly accurate. But here's again what I'm going to stress here. Watch the y values as they get really close to 2, but they're not passing it. And I'm going to be watching for that in your graph. If your graph just randomly goes down here somewhere, I'm going to mark it wrong. Okay, we got to make sure that gets in there. And I notice I have one shift. Okay, shifts that are on the end are my up or down shifts. And even though it didn't ask me to write them, I would suggest jotting that down, and here's why. There's a direct connection between my range and an up and down shift. So for instance here, since I shifted down 2, my lowest y value now is at -2. Okay, for my first 2 problems, it was at 0. I didn't have any up or down shifts, but here I do. These will always have a direct connection to each other. Okay, but only if it's up or down. And the reason I mention that is when we get to number 4, I'm going to have another shift, but what direction is this one? Okay, it's right 4. It's not up or down 4. So my range isn't going to get affected. So when I go to type this one in, And again, I'm just going to type in what I see. This time the minus 4 is up in the exponent. We make sure it's there. We can take a peek at it for a minute here. Should be growth. Yep, there it is. It's shifted over to the right. And so I can start to plot some of these points. And I notice as I'm plotting them, the values keep getting closer and closer to 0, but they're not going through. And that's because I didn't shift up or down at all. My range is back to 0 again. Only time this number changes is up or down shifts. Otherwise, we leave those the same. Shouldn't be too bad of a deal. Speaking of shifts, if f of x is 7 to the x and g of x is 7 to the x minus 3 plus 2, explain how to obtain g of x from f of x. What is the transformation? What are the shifts, okay? You've got to know that language. I may use shifts tomorrow, I may not. So again, the first one won't ever tell you anything. It's always the second one you're going to be looking at. So what two directions do that minus 3 and that plus 2 represent? Right 3, because again, this is always my left and right. It's the opposite of what I would think. And this is my up-down, but it goes along with exactly what I think it would be. And I suppose you could type it into your calculator and look at the picture if you really wanted to try and see it that way. That would work. But again, it's just easier to know my shifts as I'm working along and get that done that way. Now we're going to go application mode. Okay, notice the formula to use is right there. Don't get creative. Okay, don't try to use a different one. Just use the one I have. The amount of radioactive isotopes decreases 4.5% per year. Okay, decreases means we're minus. So again, if we're not sure on our decimals, you can always divide by 100 to get that. There's my A value. There's my starting amount. Okay, and there's my T. So basically, I've got everything I need to figure out my Y value. So I'll write down my equation. 1 minus, because it's decreasing. And since it's only asking me about 15 years, I'll go ahead and put the 15 in. If you wrote X, I would mark it wrong. But to get the amount, I got options. Since I'm only looking for one value, I could just type this in a regular old calculator. And since we're talking about grams, we'd go to the nearest whole. I won't scream if you go somewhere else with this. If you wanted to stay in y equals, be my guest. You would have to use the x if you did that one, though. And you would just scroll down to 15. There's the 122.8. Again, we just round it to the nearest whole. Both work. So either one I'm A-okay with. All right, 7. City's current population is 45,600. A. But it grows plus at 2.3% each year. Write an equation to represent the city's population. Then calculate how many years will pass before the population reaches 60,000. Okay. So, again, the equation's right here. And this time, I'm going to go ahead and use x. You're like, well, why is that? Because what am I trying to find? How many years before it reaches 60,000? In other words, when is y going to be greater than 60,000? I'm going to need to go to my calculator, unless I want to do a lot of guessing and checking. And I'm going to imagine most of you don't want to do a lot of guessing and checking, and I don't blame you. So I get it typed in. I'm very careful to make sure I'm typing it in correctly. I pull my chart, and again, Y is what I'm looking for. Once Y goes over 60,000, first time it does, right here, that X value is how long it's going to take. So this is going to take about 13 years. We're just looking at it that way. Again, just keep using the formulas that are there. You invest part of your summer income in an account that collects 4%. Interest continuously. Equation's right there for continuously. How long will it take for the account balance to triple? Okay, so let's see. So my A value, wait a minute. They didn't tell me how much I started with. When they don't tell you how much, you get to make it up. So I'm going to make my principal 1,000. You could make it 100, 1,000, a million, $1. I don't really care. The E is a value. Again, to get E, we type second and natural log. These are the types of things you will need to know tomorrow, though. If you walk up to me and going, how do I get E again? I'm going to say, well, you didn't practice and you weren't paying attention yesterday. You've got to focus. So second ln to get that. I know my rate. How long will it take for the account balance to triple? Whatever you started with to get to 3 times as much. So basically what I'm going to be doing here is I'm going to type this part of the equation in, not the 3,000. So 1,000, second, natural log, ln on the left side. It makes it an exponent for you. And I just type in my 0.04x. Just like we dealt with in number 7, once I get that typed in, I'm going looking until my Y value hits 3,000 for the first time. X will tell me that's a long time. 28 years. Mercy. I might find another plan. All right, and then the last one, more interest. Suppose you invest $1,200. Again, labeling, not a bad idea. Paying 5% interest, compounded monthly. Happens 12 times a year. Find the account balance in 9 years. Oh, they gave me numbers for everything this time. So I'll jot those down. And again, just follow the formula. I don't need to put it into y equals this time. Again, you can if you want to. I'm not going to, though, because I'm not looking for multiple values. I'm looking for one. Now I just got to make sure I type it in here right. Take a minute here. Yes, 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 yes. Okay, so again, we're talking about money this time, so we can go to the nearest cent. Again, a little common sense. $1,880.22. Awesome. All right, last one. You're trying to decide which apartment to rent. Choice A's contract charges $300 a month, but the cost increases $20 each month. Choice B's contract charges $200 a month, but will increase 4%. Which apartment is more economical? Justify your answer. Be sure to explain the time of the contract. Okay. So we've got A, which would be $300. And then it's increasing by $20 each month. You're like, well, wait a minute, that's not one of the equations we've been using. We're going to kind of expand our horizons here a little bit. So kind of ignore my parenthesis looking thing. It's a plus. Because then if I did it 6 months, it'd be 300 plus 20 times 6. If I did it for a year, it'd be 300 plus 20 times 12. Okay? B charges $200 a month, but will increase by 4%. Okay, that's more like the ones we've been looking at. which apartment is more economical? You're like, well, how am I supposed to figure that out? Well, this one's probably better because, it's only 200. Here's the best way to go about this if you don't want to spend like a lot of time doing it. We're going to type each of these into the calculator in a separate line. And this is going to allow us to look at both of these together. Now, I could look at this graphically, but I think looking at it in the chart is going to be better for us to be able to see what's going on. So let me go back up to 0 here because this will be at the very beginning. Okay, so at the beginning, Y2 is my choice B, and it's cheaper. And as I scroll down, okay, let's go to a year here. That's still a lot cheaper. Let's go to 2 years. Wow, it's still cheaper. Whoops, 2 years. Come on, Harty. And I notice no matter how far I've gone down, the second column keeps being cheaper. Okay, so we would say B is more economical. And even if I went down to 36 months, which is 3 years, okay? So even 3 years later, it is cheaper. And even if you only did it for 2 years, like 20 months or 24, and you saw that, that's fine. But you can't just say B is cheaper. Okay, why? Because it is. No. Or you can't just look at the first month and go, well, the first month cost this. I hope you're not jumping from apartment to apartment every single month. Man, it'd be a lot of moving. But I mean, I wouldn't want to say, in month 1, it's still more. Just expand it. Go out to a year or 2 years at least. I might have gone a little bonkos here going to 3, but that's okay. Again, only thing that changes tomorrow, a couple extra problems at the beginning, like 1 and 2 were, and one more app. Otherwise, you're set. It'll be set up the same way. There'll be equations there to help you out. Go back over this, grab an extra maybe, work this out. You got this. I'm out.